Hello everyone, in this video we're going to explain two Python programs developed in Tony based on Chapter 9, Image Restoration, Segmentation, and Deep Maths, from the book Raspberry Pi Computer Vision Programming. This chapter introduces techniques used to repair damaged images, divide images into meaningful regions, and simplify visual information for later analysis. These topics are very important in computer vision because they help improve image quality and make visual data easier to process. For this work, we created two programs. The first one is focused on image restoration using inpainting with the Tilia and Nevayer strokes methods, and the second one is focused on image segmentation and quantization using k-means clustering with different values of keys.
The first program was developed to demonstrate image restoring using OpenCV's inpainting function. In this case, we use a damaged image and a masked image. The damaged image contains several white marks placed over important parts of the sense, and the mask indicates exactly which regions must be repaired. In the code, the image is loaded in color and the mask is loaded in grayscale. Then the program applies the inpainting function two times. The first restoration uses the Telea method, and the second restoration uses the Navier-Stokes method. Both methods uses neighboring pixel information to restructure the missing parts of the image. After that, the results are converted for visualization and displayed in a 2x2 arrangement. And this allows you to compare the damaged image, the mask, and the outputs of both restoration methods in a single figure. In the results, we can observe that both methods were able to remove the artificial damage from the image. In the damaged image, the white lines and shapes cover regions such as the sky, the house, the road, and the car. The mask correctly identifies those damaged areas in white over and black background. The Telea method produces a smooth restoration in most part of the image. The damaged lines in the sky and the road are removed successfully, and the repaired regions blend well with the surrounding colors. The Navier-Stokes method also restores the image correctly. Its results is very similar, but some repaired regions show slightly different smoothing, especially near complex objects like the car and the house. Even so, the missing marks are also removed effectively. This program shows that image restoring can recover damaged areas using the information around them, and that both in-painting methods are useful for this task.
Thank you. The second program was created to demonstrate image segmentation and quantization using k-means clustering. First, the original image is loaded and converted so it can be displayed correctly. Then, the image is reshaped into a list of pixel values, where each pixel is represented by its red, green, and blue components. This allows the k-means algorithm to treat each pixel as a data point in color space. Next, the algorithm is executed using three different values of k, which are 2, 4, and 8. For each value, k-means groups the pixels into that number of color clusters. Then, each pixel is replaced by its representative color of its cluster, and a new simplified image is reconstructed. Finally, the program displays the original image together with the three quantized outputs, so we can compare how the image changes as the number of clusters increases. In the results of the code 2, we can clearly see the effect of changing the value of k. With k equal to 2, the image is reduced to only two major color groups. Because of that, most of the fine details disappear, and the scene becomes very simplified. The general structure is still present, but the image loses a lot of information. With k equal to 4, more shapes and objects become recognizable. The house, the road, the car, and the sun are easier to identify. And the image keeps a better balance between simplification and detail. With k equal to 8, the result is much closer to the original image. More colors are preserved, which makes the windows, wheels, and objects' boundaries easier to see. This version keeps more visual quality while still applying segmentation and quantization. So this program shows that k-means clustering can simplify an image by reducing its number of colors, and the value of k directly affects how much detail is preserved.